So one of the first things I want y'all to watch is this. We talked a little bit about singularity in labs. This is actually what singularity is and the way it works. What it's doing is that it's trying to move different positions, but because two joints line up, it causes it to do unpredictable movements. Because what it's trying to do is get away from that axis where they're both one. So this is why when y'all start the labs, you have to put the gripper down to a 90-degree angle. It keeps certain parts of it doing things like that. So the two joints that are coming together are the one here, and that last one. So that's what a singularity is, guys. What happens is that when you get into a singularity, it actually, how to say this? So singularity would be two joints lining up. And the robot doesn't like that, so it tries to get it out of that singularity by making these unpredictable movements. Now, it does not work that way if you're doing a joint jog. That's where you're controlling each joint individually. It'll do it in run mode. It'll do it in tool, and it does it in Cartesian, or world coordinates. So again, that's why we have y'all tilt that down, just because it keeps the unpredictable movements to a bare minimum. That's exactly what you want, because y'all saw how fast that's moving. If you get something in the way of it, it's toast. All right, picking up where we left off last time. So we talked about human factors, right? Because humans, we are naturally curious creatures. So thus we always have to sit there and go, what does this do? So human factors is one of the biggest issues with safety on anything, because think about it this way. How many of you have ever climbed a fence to go into somebody else's yard or something? Everybody's kind of done that. Because why? Everybody sits there and goes, well, the rules don't apply to me at this point. But they do, and it's not what you're supposed to be doing. Okay. So safety monitoring involves the use of sensors to indicate conditions or events that are unsafe or potentially unsafe. It is not used to protect humans who happen to be in the cell, but also the protection of the equipment in the cell. Because one of the things we really don't want to do is wipe out the equipment, wipe out the humans, wipe out anything that's in there. That would be kind of bad. So some of these can be very, very simple. Some of them are like a vision system. If you have a vision system, that's a very complicated system to set up. Once it gets running, it's fine, but setting up takes a little time. Okay. So the people that design these work cells do it with the purpose of, is somebody going to be in there? Where does my equipment need to be laid out so my robot can get to every piece? making sure you have door interlocks and doors in appropriate places so that you can get in and out access to it. I mean, there's a lot that goes into setting things up for this. Okay. So, levels of robot safety, you have level 1, which is the outermost perimeter. Level 2 would be opening the door and stepping in, and level 3 is getting right up next to the robot. What are you supposed to have in hand whenever you walk into a robot work cell? Either the pendant or a remote operated dead man switch. Okay. That or the robot just needs to be off or hit the E-stop so it can't move and get you. Bad thing about robots is that they perch. Most of the time, if you're working a program, the robot has what we call a home position. And if that home position is just sitting there waiting at it, right? What it's waiting for is an input signal from a sensor or from the computer saying, go do your job. That's why you do all sorts of things to avoid said problems. All right. Level 1 are intended to detect that an intruder has crossed the perimeter boundary of the work cell without regard to the location of the robot. 2 is to detect the presence of an intruder in the region between the work cell boundary and the limit of the robot workspace. And 3 provides intruder detection in the work volume of the robot. Now, I'll go ahead and tell you now, one of the things that we have gotten to these days is making sure that people really just can't get into these work cells that don't have authorized access. Okay? Level 3s are not used. I won't say they're not used at all, I'll say they're not used frequently. Main ones that you'll see dealing with robots are level 1s, maybe level 2s. Why? Because we have a barrier up around these robots. And I do mean a barrier. Okay? You have a fence all around this thing. Okay? Anybody taken sensors before? Okay, so how expensive are sensors? Very expensive. So why are you going to, let me rephrase that. Whenever you're dealing with money and automation, is anybody going to want to spend more money than they have to? No. So I won't say 99% of the time, I'll say a good 80% of the time, that outermost barrier is probably the biggest thing stopping that robot from doing anything to humans. Because the second you open that door and those interlocks disengage, that's when you're going to have everything just shut down. Because that's the safeguard that is keeping you from getting hit by the robot. Does that make sense? So yes, there can be 3 levels, but the main level you're going to encounter in field is that outermost gate set. Why? Because it's cheap, it's easy, and it's convenient. Doesn't take very much to do it. Make sense to everybody? Yeah, the more sensors you add up to this thing, the more expensive it's going to be. So there are 2 common types of safety sensing systems. You have pressure sensitive floor mats, which this is how the automatic doors around the world tend to work. You step on the mat, doors open, right? If you don't have enough weight on that mat, will the door open? It will not. And then you have one of the more popular ones, especially these days, you have what's called a light curtain. Anybody know what a light curtain is? So a light curtain, for those of you that don't know, you have two rectangular pieces, and depending upon the setup you buy, what you're looking at here would be beams of light going back and forth between these two constantly. As in, it's a never-ending cycle. So think Mission Impossible, where you have all the laser beams, and if you break the beam, what happens? The alarm goes off in the movie. In this case, something similar happens. You have infrared beams that constantly shoot at each other, and they're receivers. So what that's doing is keeping a barrier between where a robot's or workstation's work is happening versus where the human stands. And if you trip one of these light curtains, it actually will trigger the whole system to stop. Most of the time, if you have an operator inside the work cell, they have to make sure that their hands are off everything and step out of the work cell so that they can activate the robot. That is a very, very common practice these days. Why? Because it's a lot safer. So, any questions on those two? Now, why would we use the light curtain instead of the pressure mat? Comes with the fact that if somebody's having to stand there all day, your feet are going to hurt and the mat's going to deteriorate pretty quickly. The thing about the light curtain is that you have to wipe it down periodically to get any dust and debris off it, but otherwise it just runs all the time. No problems. Everybody good? So we have proximity sensors that can be located just about anywhere. Proximity sensors are great in the fact that they are looking for the position of something. Now it can be a solid, liquid, or gas, but all it's doing is looking for input. Okay? So safety monitoring strategies that might be followed by the work cell controller would include the following schemes. Number one, the complete shutdown of the robot and other equipment upon detection of an intruder. This is, again, the most common way we use as safety. Why? Because if there's somebody in the work cell, we do not want that robot running unless they've got that teach pendant in hand and have it in teach mode. Warning alarms, some do, some don't. They make some of these door interlocks to where you either have to have a passcode or you have to have the key to be able to get in. And by the way, guys, when we say safety barriers, we're not talking something that sits about 4 feet high. No, these fences are generally 6 feet to 7 feet tall. And the mesh on them is about an inch, maybe 2 inches. So you can't even get your fingers through the mesh. Okay? Much less try and clamber over it. But you definitely will see things like warning alarms. You know, kind of like in your car, what goes off before you put your seatbelt on? That silly warnings thing that goes beep, 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 beep. Until you sit there and put your seatbelt on and finally you just get blessed silence. One of the biggest things we do, especially with robot controllers, is we bring it down from full speed run to a safe speed that you can avoid the robot if you have to. Directing the robot to move its arm away from the intruder to avoid collision. That's true. Directing the robot to perform tasks away from the intruder. So why would we need to have anybody in that work cell at all? There's two reasons. Anybody can think of them? Cleaning something up because something spilled in the floor, or general maintenance of the equipment and or robot inside that cell. Does it make sense? You know, if the robot happens to accidentally drop part of the product that it's trying to make, somebody's got to go in and pick it up. But that comes back to authorized personnel only, because you don't want just somebody off the street able to get in with that robot without the sense that these things are not safe to be around like that. So you might want to watch what you're doing. Okay. So safeguarding. Most accidents occur as a result of unsafe acts by the worker. So it's generally not equipment failure. It's because you either, as the worker was either what? Improperly trained? Careless? Anybody else? How about just straight up not paying attention? Because the fact of the matter is, the more you do something that's a monotonous task, the more your attention tends to what? You start getting, I don't know what else to call it, but something like ADD, where you're just sitting there going, butterfly. I'm busy doing this, but butterfly. Your mind begins to wander. It's kind of like, how many of y'all remember your drive here today? Just about nobody will remember every detail of how they got here. Why? Because your brain has what I like to call an automatic mode. What that means is that your brain is sitting there just going, okay, I've done this 1,000 times, just cruise control. That's exactly what your brain does. So one of the things that is the biggest thing with this is just not paying attention, not having focus on what you're doing. Does that make sense to everybody? Because I think all of us have actually gotten caught doing something like that, right? Where all of a sudden your attention is just completely wandered off, and then you come back and it's like, oh, wait, what was I doing? So you have improperly trained operators, you have careless people that'll do things, component failure, other unsafe conditions in the plant. There's 1,001 ways that it result in injury. Most of the time it is an accident just because somebody wasn't thinking at the time. I hate to say it though, there are times where people do stuff on purpose. Always depends on the person and their honesty sometimes. But improperly trained operators, programmers, and all that, yeah, if you don't know what you're doing, you might want to ask before doing. So major concern and safety of all personnel involved with industrial robots is very important. According to the National Safety Council, the principal hazards associated with robots are being struck by it. This is why you do not go in there without knowing what you're doing. If you know what you're doing, you know how close you can get to these robots to do what you need to do. If you don't know what you're doing, you're going to hurt yourself just because you got up in the robot's work area without slowing it down and making sure you're out of the way of the next thing it's going to do. One of the best things you can do if you have to go in and reprogram something on the robot, or if you have to go in and fix something on the robot, you need to know the program pretty much backwards and forwards. Does that make sense? Why? Because that way you can predict when that robot's going to swing around. or have to come down and actually catches your finger or something. If you know ahead of time what the next sequence is, you can do just fine with it. So being trapped between a moving part of a robot and another machine, object, or surface, being struck by the workpiece, tool, or other object dropped or ejected by a robot. Again, this kind of goes back to people that aren't properly trained. They're careless because they really just don't care. They're there for a paycheck. And then you've got the ones that, they put on autopilot and they just aren't paying attention. Anytime you're in an industrial setting, you have to pay attention. So robot safeguards. We erect physical barriers around the entire perimeter of the robot's workspace. You have a guard containing sensing devices that automatically shut down the robot if a person or object enters its workspace. And put sensitized doors or gates in the perimeter barrier that automatically shut down the robot's movement when they're open. Questions on that? So even though it's difficult to, let's put it this way, there is no such thing as a risk-free environment. I don't care who says that they have a risk-free environment. There is not. We're human. We can find ways to hurt ourselves. Right? All things in the world have some form of risk. Nothing else, you can think of the fact that if you have a tile floor, eventually you got to mop it. If you have a wood floor, eventually you got to clean it. Then you have a risk of somebody slipping on something, right? So there's no way to create a risk-free environment because there's always the possibility of a malfunction or the violation of good safety practices. But the way to minimize these potential errors, how many of you have ever had to sit through safety orientation at work? I think just about everybody, right? They always got to do some sort of safety orientation. Working retail, they sit there and they talk to you about things like Code Adam, which is if a child gets lost in a store. You have the basic, don't leave ladders out on the floor. It's very naughty. Don't do that. Or my personal favorite, where they make you sit down and watch an hour-long video about the do's and don'ts. Lift with your knees, not your back. That kind of stuff, right? But safety training works, believe it or not. It does work because if you make people aware that this is a hazard and you need to pay attention when you're around this hazard, it drops off the hazards, makes things better. Dependable machine design. I'll go ahead and say this about machine design. Yes, you can design it to be the safest it can be. However, if somebody removes things like guards, or they don't know what they're doing and they put their hands in the wrong place, or you have the machine, all machines will eventually break down, right? I don't care how pristine you keep it, all machines will break down. So dependable, yes. Unbreakable, nah. All things will break. So proper layout of the work area, making sure that everything is set to where you're not having, as the human, are not overstraining, but you also don't want to overstrain the robot. Safe position and clear visibility for programming. Most of the time, if you're having to do reprogramming on a robot, as y'all probably noticed, you can't really do it from outside a barrier, right? You have to kind of sometimes get in there, and you're going to see it more and more as you have to get more and more precise with these robots, is the fact that a robot can go down to the same place within a hair's width, if not less. Okay? So sometimes if you have to have extreme precision, yes, you have to get up close and personal with this robot. But you have to do it with the thought of what am I, the best way to prevent an accident at that point is to think through the steps you're going to have to take to get to that point. Does that make sense? Um, Establishing proper maintenance procedures. This is a big one because what is the best way to keep your equipment running? Good maintenance, or what's called preventative maintenance. Instead of waiting for something to break, fix it before it does. Know what's going to go out sooner rather than later, like your car. What's the most common bit of maintenance on your car? No, as far as maintenance goes, huh? Oil change. Biggest bit of preventative maintenance that you have, right? That's what keeps your car going. So you have that as an established maintenance procedure, because how often are you supposed to change the oil? About every 3 to 5,000 miles. So proper maintenance procedures really can save things, right? Because generally taking it into the mechanic to get an oil change, they can also take a look at the whole engine and say, hey, you know what, this is starting to look a little rough. Your radiator's cracked, or you have bad spark plugs, whatever, right? Having that maintenance procedure keeps things from getting to a crisis point. That's the last thing you ever want to do, right? Having to fix something from the crisis point just means that everybody's breathing down your neck and telling you, you got to get it done, got to get it done, got to get it done. Move, move, move. Adequate installation performed in the presence of safety personnel. Most equipment these days, you have to have somebody on site watching as you put this in. Why? Because the person that's installing it might not be aware of all the safety procedures your company has to follow in order to have that piece of equipment. Does that make sense? Obeying safety rules and regulations of authoritative organizations, OSHA again, right? We like OSHA because they keep us safe, and they keep businesses running. So, safety guidelines. The unexpected robot movements are a concern of employees for obtaining further guidelines on robotic safety. Essentially, workers need to know how to deal with and around the robots, just because if they happen to get in that workspace because you have the robot on the floor, you really want them aware that this thing is not just, it's not off just because it's perched. Does that make sense? Researchers have developed many guidelines pertaining to safety issues in robots. If it's not moving, this is the biggest one right here. If a robot is not moving, don't assume it's not going to. Because all it's generally looking for isn't for somebody coming across the barrier. It's going, okay, is my next work piece here? Right? Just because it's not moving, don't assume it won't. If the robot's repeating a pattern, don't assume it will continue. What that is essentially saying is just because it's running the program doesn't mean it's going to run it perfectly all the time. Sometimes glitches happen. Does that make sense? Always be aware of where you are in relationship to possible positions that the robot may reach. In other words, be very aware of where the robot is, what it's doing, and if you feel like you're in its path, you might want to move. Questions on this, guys? All right. So these are the actions of a human being. You have the decision unit and the operation of a robot. So push button and stop mode. I mean, there's a lot of different ways that everything can go through and go wrong. All right, so be aware that there is power. Indicator lights should be on if the power is on. All right. Teaching or programming and service and maintenance are the only authorized reasons for entry into that workspace. Before activating power to the robot, employees should be aware of what it is supposed to do, that all safeguards are in place, and no foreign materials are present in the work envelope. Notify supervision immediately when an unexpected interruption to the robot's normal work cycle occurs. Report any missing or defective safeguards. Should be an S there. Should be or. Report any missing or defective safeguards to supervise. Somebody really just messed up this whole sentence. It should not be supervision, it should be supervisor. Immediately, check all safeguards at the beginning of each shift. So just like a forklift, how many of you have ever had to go through forklift training? Some of y'all have, some of y'all haven't. What are you supposed to do with a forklift before you get on it every day? Anybody know? Generally, they give you a checklist that you have to go through and make sure that everything's working properly, right? That is one of the big rules of operating a forklift is you have to make sure, you have supposed to check the oil levels, you're supposed to check hydraulics, see where your forks are they in good shape, that kind of thing. Make sure you've got a full tank of gasoline, electrical, and or any other substance it runs on. So any machine that you use at any point, you need to kind of go over it just a little bit to make sure that there's nothing that's come loose or come out of place. That's essentially what this is saying, right? One of the things that you are actually supposed to do, I know most people don't do it, what you're supposed to do every morning is that whenever you go out to your car, you're supposed to what? Same thing, you're supposed to inspect it from nose to tailpipe. Nobody does that, but you should at least walk around. The least you should do is walk around and check your tires, make sure you don't have a flat. Make sure that there's no liquid pooling under your car, stuff like that. That's the kind of things that this is talking about. Is everything set and ready to go, or do I need to go repair something? So safety is an important component in industrial automation. Okay. I'm not going to read all this to y'all because y'all can read it yourself. But safety is something that a lot of people don't take seriously enough. It truly is. If you don't have it in your mindset that safety should always be first, you need to put that in your mindset because otherwise accidents can, and will happen. Okay? All right. I'm going to